Hope you're doing fine, and I'm really excited to be with all of you here today, virtually of course, and chat about technologies and products I truly adore. Today we will talk about Azure Synapse Analytics, or to be more specific, about Serverless SQL Pull within Synapse Analytics from a perspective of Power BI developer. We will go and try to cover some interesting scenarios and understand how these two products work in synergy. So make yourself comfortable, grab some refreshment as we are preparing to kick off. Laurie made a short introduction, so I will not waste too much time, just a few more sentences. My name is Nikola Ilic. I'm originally from Belgrade in Serbia, but since last 5 years, I live in a beautiful city of Salzburg in Austria, where I work as business intelligence developer at company ITSP Services. Living in Salzburg was the reason why I've chosen my nickname, Data Mozart. I guess you all know that Salzburg is worldly famous as the birthplace of Wolfgang Amadeus Mozart, so I was brave enough to use his last name as part of my nickname. And that's what my motto is: make music from your data. You can find me on the web. I'm regularly blogging at data-mozart.com. I'm also quite active on LinkedIn and Twitter, so feel free to ping me or connect if you like. Other than that, I'm Microsoft Data Platform MVP and Microsoft Certified Trainer. Privately, father of 2 kids and true football and Barca fan, as you can conclude looking at your screens. So let me briefly walk you through the contents of our today's presentation. We will start with quick comparison between traditional and modern data warehousing concepts in order to put our discussion in the proper context. Then I will introduce you with Azure Synapse Analytics and core components of this platform, which will enable you to better understand the next unit. The next unit is Serverless SQL Pull. What is Serverless SQL Pull? Why should you consider it for your analytical workloads? And finally, in which scenarios would it make sense to go this direction? We will then examine different techniques of using T-SQL to retrieve the data from semi-structured and non-structured sources, such as CSV or Parquet files, or NoSQL databases, for example, Cosmos DB. Straight after that, I will cover the best practices for using Synapse Serverless SQL Pull and how to get maximum from this engine. Last but not least, as I'm sure that most of you are most interested to hear how much this cost. Is this, a match made in heaven, Power BI with Synapse, or just an expensive, fancy new toy? We will talk about pricing, what counts for the pricing, and how to manage your costs, and finally, how to save money in your wallets. There will be, of course, a few demos along the way, so you can get a better feeling of different features within Synapse Serverless SQL Pull. I know that this session is targeting Power BI professionals, but to be able to follow along, I will assume that you have some knowledge of T-SQL, as I will often refer to terms and concepts related to traditional SQL Server and its language, Transact SQL. So if you're completely new to SQL, maybe you will find it challenging to absorb everything that follows. Nevertheless, please don't leave the session because of that. Just feel free to ask questions if needed. Okay, here we are. So the story starts with a quick look back to some concepts that were and still are omnipresent in the world of data. These days, there are multiple ongoing discussions about the relevance of traditional data warehousing concepts in today's state of play. I will not go, of course, deep into these discussions. I will just express my belief that traditional data warehouse is far from being dead. It's more in kind of evolution phase, adapting to multiple new challenges typical for large data volumes or different flavors of data sources. Let's call it that way. So in a typical traditional data warehousing scenario, as you can see in this illustration, you would go and collect your data from multiple different sources, perform some transformations, data cleansing, and so on. And then you will put this consolidated data into a relational data warehouse. This was and still is the focal point of your reporting solutions, a single source of truth for your data, and you could build then various reports from there using a whole different range of tools, such as if you're talking about Microsoft solutions and you are old enough like me, for example, Crystal reports or SQL Server reporting services, or most recently Power BI, of course. You could also build an additional semantic layer using SQL Server analysis services or Azure analysis services to create cubes, both tabular and multidimensional cubes, and then target those cubes with reporting tools that I previously mentioned. And don't forget good old Excel too as a reporting tool. And if you think of traditional data warehouse, as its name suggests, like of a warehouse, you are close to truth. It is like a large store, and modern data warehouse is like a extra big distribution center. In this traditional large store, products are already unpacked, prepared, ready for use. So it's like someone went there and extracted products from the boxes, transformed their original package, and loads the shelves in the store. I guess you recognize the analogy with extracting, transforming, and loading, or ETL in our data context. On the other hand, in this big distribution center, well, you see how the items are being stored. But if I need a box of, let's say, beer, I can also pull it directly from here without needing to go to my local shop to take it from the shelves. As you can notice in this illustration, modern data warehouse accepts data from the whole range of different sources, structured, semi-structured, non-structured. So this can be graph-like data coming from social networks, data streams from different devices, data from JSON documents, CSV files. So literally anything you can imagine what is capable of storing some kind of data. Now this big distribution center can keep the data in its original form without need to apply some additional steps in order to prepare this data for further analysis. With that in mind, whole range of different data professionals can benefit of having a solution like this. Data analysts can use Power BI or similar reporting tools to create reports over this data, while, for example, data scientists or machine learning engineers can create and train their models right away. The key concept here is that unifying experience that modern data warehouse provides. That being said, there are multiple benefits that modern data warehouse provides. From technology perspective, modern data warehouse brings the following advantages. It is always, or let's say almost always, available. It scales to extremely large amounts of data. It's also flexible because you can quickly get insights from literally any data source. And that means that less time is needed for data movement and data preparation, which in the end brings reduced overall ownership costs. Let's now talk about Synapse Analytics. Do you recognize the object you see on your screen? Yes, exactly. That's the famous Swiss knife. You can use this device to cut the paper, open a bottle of wine or beer, or even cut some smaller items. And all of that using one single tool. So if you're asking yourself, what on earth does Swiss knife have in common with Synapse? Well, you can think of Synapse as a single tool that can satisfy all your data workload needs. For example, do you need to import data from multiple different sources? Synapse can do that. Do you need to transform data before serving it? Synapse can do that too. Do you need to store the data? Synapse can do it for you. Do you need to query non-relational data or even files directly? Synapse can do that. Watch out now. Do you need to query non-relational data or files directly using plain old T-SQL? Synapse can do that. What? Yeah, I hear you say it again, Nikola. Yes, you can write T-SQL to query data from CSV, JSON, or Parquet files. But more on that in a few minutes. Do you need to build machine learning models? Synapse can manage this for you. Finally, do you need to create your Power BI report directly from the Synapse? Yes, that is also possible. As you may rightly conclude, Synapse is a one-stop service for all your data tasks. Or if someone asks you to define Azure Synapse in 3 words, you can freely tell that it's an end-to-end analytics solution. Here is the quick, let's call it 10,000 feet high overview of different components that make Synapse Analytics integrated analytics solution. For SQL professionals, there are two pools in Synapse. Dedicated pool, which is the official successor of former Azure SQL Data Warehouse. And then there is a Serverless SQL Pull, which is the highlight of today's session. In this illustration, this is a little bit outdated illustration. Before Serverless SQL, before Synapse Analytics went to general availability, Serverless SQL was called on-demand pool. So don't be confused. In reality, this is Serverless SQL Pull. Then folks familiar with Python, Scala, or Spark SQL can leverage usage of Apache Spark Pool for processing large volumes of data. When it comes to storage, there are also a bunch of possible options to choose from, starting with traditional relational way of storing data in SQL Data Warehouse, then also Spark tables, Azure Data Lake storage, and Data Lake, all the way to non-relational document style storage mode in Cosmos DB. You can also orchestrate data movement using Azure Data Factory pipelines and mapping data flows. Finally, you can quickly visualize your data using, for example, Power BI. And watch out, here is the key takeaway. You have all these tools under one roof, either natively, either as linked services. And you can build, manage, and deploy your end-to-end data solutions from within a web-based user interface called Synapse Studio. We will take a closer look to this tool later in the session, as we now need to lay some more theoretical background. As you may notice on the previous illustration, Synapse Analytics offers 3 different analytics pools for performing different computations over your data. 2 of them are SQL-based, which means that you can use familiar T-SQL syntax to query your data. Also, 2 of them are provisioned, dedicated SQL pool and Apache Spark pool, which means that you need to set some kind of infrastructure in advance. And more important, that means that you will be charged not only for computing power, but also for the storage you are using. Now, when it comes to integration with Power BI, as dedicated SQL pool works more or less the same as traditional SQL database, and Spark Pool is out of the scope of this session, I would like to explain in more depth Serverless SQL Pull, part of Azure Synapse, and this is a, let's say, new thing, and how it works in synergy with Power BI. Again, before we dive deeper into detailed overview, let's take a quick look from our aeroplane on its architecture. So the core component of Serverless SQL Pull is distributed query processing engine called Polaris. So let me zoom it a little bit. This thing here, which runs on control node. This control node represents the brain of the whole architecture, and control node splits the query into smaller chunks and forwards them to compute nodes down there for execution. So instead of a query, we have something we call task, and task is nothing else but a unit of distributed query execution. So kind of part of query, imagine like that. Last but not least, unlike in dedicated SQL pool where you are in charge for defining computing power and how many compute nodes will be used, Serverless SQL Pull scales automatically to support your data workload. I promised in the beginning when I was introducing the agenda that we will try to answer to 3 key W's regarding Serverless SQL Pull. What, why, and when. So let's start with what. And I will try to keep this as short as possible, I promise. So Serverless SQL Pull is essentially a distributed data processing system, or maybe it's better to say a query service that enables you to query data directly from the data lake using well-known T-SQL syntax. There is no any cost for the resources, storage, things like that. So you will be charged only for the amount of data processed by running your queries. We will examine later what counts in the amount of data processed and how you can control it. In this moment, just keep in mind that Serverless SQL Pull is a typical pay-per-query model. And when I explain what is a Serverless SQL Pull, I like to think about it like an advanced version of Polybase or Cloud Polybase. Underlying technologies are not the same, but use case scenarios are pretty much pretty much the same. In Polybase, you don't have open row set function to perform ad hoc analysis, as everything is handled through external tables. But yes, you can think in the end about serverless SQL as Polybase on steroids. Now, as you hopefully answered what is serverless SQL Pull, let's try to examine why you would consider using it. First and most important, you don't need to set up any kind of infrastructure or clusters to make this thing running. Once you go and create your Azure Synapse workspace, Serverless SQL Pull will be created by default. And that means you can start querying your Azure Data Lake storage as soon as you create the workspace. And that significantly reduces time to analysis. As I already stressed, when you provision dedicated SQL Pool or Apache Spark Pool, you will pay not only for computing power required to satisfy your data workloads, but also for the data storage. Here with Serverless SQL Pool, you pay $0 for the data storage. Finally, learning new programming language just for querying data from the data lake can be daunting for many professionals, especially those coming from the SQL world. And therefore, one big benefit of Serverless SQL Pool is the possibility to use well-known T-SQL syntax to retrieve the data directly from the, let's say, CSV or Parquet files, or even from the documents stored in Cosmos DB. In full honesty, Serverless SQL Pool is not a magic wand that will solve all your data requirements. So it's extremely important to understand in which scenarios you should consider using it. So let's answer our final W. When would you use Serverless SQL Pool? First thing, I need to gain quick insight into the data laying in my data lake. I want to see maximum or minimum value or average value within a column, or quickly identify some outliers. I will perform basic data exploration of the data stored in CSV, JSON, or Parquet files using Serverless SQL. And then, based on my insights, I can decide how to leverage this for further analysis. Then, imagine the scenario. I want to build a kind of relational abstraction layer on top of disparate data stored between, let's say, CSV files or Cosmos DB and relational database. This way, I can build kind of a logical data warehouse without needing to physically move or transform data in classic ETL way. Okay, so let me quickly show you what I'm talking about so you can better understand this concept. Here I have some views that I've already created. Before the session, I will just show you the definitions, for example, of this view, and you'll get the point, I think. So here I'm using open row set function to directly query data which is stored in CSV file within my Azure Data Lake storage. I'm specifying some parameters here, like format. For example, this is a CSV file, and here I'm explicitly setting data types for my columns. As you can see, this is a normal, let's call it regular T-SQL statement. So I'm using cast and everything else which you should use in regular SQL. Same thing here for Parquet file, for example. Let me show you this. So here I have Parquet file, which is stored somewhere in the public space set by Microsoft. So I'm using the path to this location to define external data source. And here, by leveraging file path functions, I can partition data and import only this portion of data which is of interest to me. Okay. And finally, that's fine. So that's fine. And in the end, for example, I'm using this one. So here I'm combining this file, this CSV Parquet union file. And let me show you. So this view consists of CSV file and Parquet file. So data coming from CSV file and Parquet file from completely different sources and completely different locations. In the end, I can go and query. Let's write top 100, and let's execute this query. So I can write a normal T-SQL query, and when you see this T-SQL statement, you would imagine that these are normal views, normal tables, but in the background, our data is data coming from CSV and Parquet files. I could easily go and combine data from Cosmos DB also if I created a view over it using Synapse Link. So as you can see, here I got my data returned, and yeah, you can encapsulate all the logic in one SQL statement and then expose this to end user. Okay, so going back to presentation, third scenario when you want to use serverless SQL is when you want to perform simple but at the same time scalable data transformation within the data lake itself using the language you know, and this language is T-SQL. As you go and transform your data, it is quickly available for further digest by either reporting tools, for example, Power BI, or if you need to load it to a relational data store, let's say Azure SQL DB or dedicated SQL Pull. So how do you access Serverless SQL Pull? By default, Serverless SQL endpoint is provided to you with every Azure, whenever you create Azure Synapse workspace, and you can immediately start querying your data using either Azure Synapse Studio or usual suspects, as I like to call them, SQL Server Management Studio and Azure Data Studio. So let me show you quickly how to connect to Serverless SQL Point, both from Synapse Studio and from SQL Server Management Studio. So here I'm in my Synapse workspace, and from there I can go and open Synapse Studio. Here you can see, let me zoom it a little bit, your serverless SQL endpoint, which is important to have when you're connecting from external tools like, for example, SQL Server Management Studio or Azure Data Studio. So if we open Synapse Studio, let's wait for a few seconds. There are a whole bunch of possible options here that I would need maybe another separate session for this. For you to start quickly digging into data, you would use Data tab. Click on it so you can create databases here. As you see, I have one database, and as a linked services, you can add a whole bunch of different services like Cosmos DB, Power BI, etc. So here I have my data lake storage, and I will open it just quickly to show you how this works. So I have folder called data, and within this folder I have some CSV files. So if I right click, for example, on this yellow trip data CSV file, I can immediately go to new SQL script and click on select top 100 rows. So Synapse Studio will automatically generate SQL statement for me, and I can run it from Synapse Studio and quickly get results. That's the thing which I mentioned. You need to quickly do some kind of analysis to see what is the maximum value or minimum value within the column. You can literally in few clicks, you are good to go. If you're connecting from SQL Server Management Studio, first I need to grab my serverless SQL endpoint. So I will copy this to clipboard. And then if I'm connecting from SQL Server Management Studio, here I'm already connected, but let me show you how it's done from the scratch. You should click on connect database engine. Here you will paste your serverless SQL endpoint and provide login credentials, of course. That's it. Same thing applies to Azure Data Studio. Okay, so that was quick intro how to access serverless SQL endpoint demo. We saw this, and let me also show you before we proceed further how you can connect to serverless SQL endpoint directly from Power BI and let's say import the data into the tabular model or perform direct query over the data stored in Azure Data Lake storage. So here I have an empty PBIX file. I will go to get data. For Power BI people, this looks familiar, and I'll start typing Azure. I will choose Azure SQL Database as a source. Click connect, and now I will paste my serverless SQL endpoint here. You see that you have regular options to import or direct query your data. I will choose import mode, and let me show you once we get a possibility to choose. Okay, I will choose this CSV Parquet Union view as a data source, and I can immediately go, for example, in Power Query Editor and do some transformations on data before loading into Power BI, and that will work perfectly. For example, let's say that I need only first 2000 rows. Let's wait a few seconds. Okay, so if I go to keep rows and say keep top 2000 rows, click OK, and I will check, but that should also fold. So query folding is not being violated by using this way of this data source. Yeah, I can click on view native query, and you can see that Power Query Engine translated our request to top keyword in T-SQL. So that works fine. And yeah, so you can quickly and easy import data into Power BI from Serverless SQL. The key reason why we're all here today is to examine how to leverage usage of regular T-SQL syntax for querying data that is stored within data lake. So let's check which options are available when using T-SQL in synergy with Serverless SQL Pull. If we are talking about database objects, here is the list of objects you can create within Serverless SQL Pull. The first and most important, and one that you will use most frequently, as you saw in our previous example, are views. You can also create multiple different schemas, same as store procedures. When it comes to user-defined functions, you can use inline table value functions. Additionally, you can create external tables, both regular and CTAs. Finally, you can create statistics on your data for increasing query performance. Things that are currently not supported are tables, both permanent and temporary tables, as Serverless SQL Pull allows querying only external data which is stored in Azure Data Lake storage. The next feature that's not supported, and that's important to keep in mind, is caching of query result sets. That means whenever you execute the query, engine will go and scan exactly the same amount of data each time. So no matter if you execute the query once or 15 times for one single query, each time this query will generate exactly the same costs. Keep that in mind, please. And I want to stress this because when I'm reading SQL blogs or watching videos, all folks, when they analyze execution plans talk about query cost. So you will often hear things like this query costs you 100 query bucks. This query will cost you 500 query bucks. Here, please forget about query bucks. We are talking about real bucks, real money. So just think twice before hitting F5 button for no obvious reason. You probably already realized that Serverless doesn't support any kind of data persistency in between data lake storage and query result set. Therefore, you can't create objects like materialized views, unlike in dedicated SQL Pull where this kind of intermediate storage is possible. Finally, you can't rely on objects like indexes or table partitions. You can partition files using file path function. I shortly explained in one of the previous demos. You can partition files using file path function, but that's a whole different story. So there is no table partitioning like in a regular SQL Server. Okay, let me now walk you through what you can and can't do with these SQL statements. So whole set of features, or let's say almost whole set of features for select statement is supported in Serverless SQL. You can also use explicit transactions on metadata objects and perform data export using CTAS statement. I already mentioned CTAS. Apologize, I didn't explain what are CTAS. So CTAS stands for create external table as select. And that you can compare it if you're coming from SQL world like select into. So you are selecting a portion of data and exporting that to external table. If you need to write across database queries, that's also supported. Also, whole set of T-SQL built-in functions, except those three you can see on your screens: Open XML, Open Query, and Open Data Source. Finally, data definition language statements are also available. So stuff like create, alter, you can write this in Serverless SQL. What you can't do, you can't use insert, update, and delete statements. You can't perform merge within your queries. Within select statement itself, there are a few limitations, namely you can't use for XML, match, and predict functions, and also query hints are not supported. And finally, you can't combine data coming from system views with distributed data. Fine. So far we discussed what is possible, in which scenarios you would consider using Serverless SQL Pull, but we still haven't explained how to get the best from this engine, or what are the best practices for your data workloads once you decide to use Serverless SQL Pull. So let's start with the list of actions you should perform in order to maximize potential of Serverless SQL Pull. By default, storage account and serverless endpoint are in the same region. However, if you are accessing other storage accounts or Cosmos DB analytical storage, try to place your serverless SQL endpoint and Azure storage accounts that you are targeting in the same geographical location, as that will reduce the latency for the data's network transfer. If possible, convert your CSV and JSON files to Parquet format. Parquet format compresses the data, and this consequentially leads to smaller memory footprint of these files compared to CSV. Additionally, Parquet is a typical columnar format and in many ways resembles to column store indexes in relational databases. Or if you're familiar with Power BI internals, it reminds of Vertipack engine. So columns are stored, they are physically separated and stored like that. And because of that, Serverless SQL engine can skip unnecessary columns when reading data from Parquet files, which is not the case with CSV. In the end, this will directly affect not just time and resources needed for processing the query, but will also reduce the cost of that query. Next thing, built-in schema inference. This feature enables you to quickly query the data in Data Lake without knowing underlying schemas and data types. However, this handy feature comes with a cost, and the cost is that inferred data types are usually much larger than the actual data types. For example, Parquet files don't store metadata about maximum character column length, and inferred data type is always varchar 8000. So if it happens that you have in the column something like let's say abbreviation of US states, which is always 2 characters, if you use inferred data types in your query, it will be translated to varchar 8000. Also, as already mentioned, you can't partition the tables, but you can partition your files. And that being said, you can instruct Serverless SQL to target only specific folders and files using file path and file name functions. This way, you will reduce not only amount of data for scanning and processing, but also the real money costs. And one bonus tip when using file path and file name functions, always cast results of these functions to proper data type. Also, one important remark, these 2 functions are currently not supported for external tables except those automatically created in Apache Spark Pool. Take advantage of using CTAS whenever you can. This is one of the most powerful features in Serverless SQL. And using CTAS, you can store, if you have frequently used queries, you can store them to a new Parquet file, and then use this single external table instead of referencing same underlying tables multiple times. So it's not a materialized view as we used to know in a regular database, but it's still kind of materialization. And this materialization occurs within the Parquet file that is stored in your data lake. On top of that, as CTAS generates Parquet file, you will get statistics automatically created when you're querying your table for the first time. So you gain performance improvement for all subsequent queries that target this same external table. Every do, as you might expect, has its counterpart in don't. So here is the list of things you should try to avoid or at least reduce to a minimum. When you're running queries on Serverless SQL Pull, carefully plan other workloads that target your storage account. Serverless SQL automatically scales, as I already mentioned, and has a built-in capacity to resolve these kind of issues. It will send requests to data lake at slower pace, but that will obviously affect the performance of your query. Again, avoid schema inference. I know that it sounds appealing to quickly, get up and running without wasting time and effort to handle inferred data types, but you should definitely spend some time resolving inferred data types to appropriate ones, as you will reap benefits later. Get rid of single large files. Instead, if you have extremely large file, split it into multiple smaller files and use file name and file path functions to reduce the amount of data that needs to be scanned and processed. With that in mind, Microsoft recommends, for example, for CSV files, that optimal data size is between 100 megabytes and 10 gigabytes. That's it. Here we are. So, do you know where does this picture come from? Remember Jerry Maguire, one of my favorite movies, if you ask me. And there is a fantastic scene when Cuba Gooding Jr. asks Tom Cruise to scream on the phone, passionately scream on the phone, show me the money, show me the money, show me the money. So remember this picture, it's exactly what Microsoft will ask you to do. I'm kidding a little bit, but in the end, I know that majority of you stayed till this point with me to hear how much using serverless SQL in combo with Power BI will cost. And I don't blame you. That's why I've intentionally left this topic for the later part of the session. So let's first examine what are you paying for when using Serverless SQL Pull. If you go to Microsoft official pages, they boldly say that you will be charged for the amount of data processed. But let's dig deep and check what counts for the amount of data processed. The first thing is amount of data read. Here you should count data itself, but also related metadata for formats that keeps information about metadata like Parquet, for example. Then amount of moved data. When you run the query, it's being split into smaller chunks. Just recall this illustration about serverless SQL architecture. So it's being split into smaller chunks and sent to multiple compute nodes for execution. And while the query runs, data is being transferred between those nodes. And this intermediate results is something you should be aware of. Same as final data transfer, so data transfer to the endpoint in an uncompressed format. In reality, you will spot the difference in this amount of data moved if you run something like select star from the file that contains 50 columns from the case when you are selecting only a few columns. Finally, amount of data written to data lake. This applies in those scenarios when you use CTAS to export query results to Parquet file that's going to be stored in a data lake. So when you sum up these three items, you are getting the total amount of data processed. So let me show you how this looks like in reality. You remember this query which I ran, selecting top 100 rows from my Parquet CSV files, whatever. And if we go to Messages tab, I can see that this query generated 796 megabytes of data scanned, and data moved is 27 megabytes. Of course, we didn't export anything to external tables, so this is 0. And if you do sum of those three values, total amount of data processed will be 823. So that's what you need to pay for. Okay, just to better explain this concept. Fine. Also, statistics, as in regular SQL databases, statistics help help the engine to come up with the optimal execution plan. Statistics in serverless SQL Pull can be created manually or automatically. In both cases, there is a separate query running to return the column on which statistics is built on. And this query also has some amount of data processed. One important thing here is with Parquet files, when you create the statistics, only the relevant column is being read from the file. On the other hand, with CSV files, whole file needs to be read and parsed in order to create a statistics, even for a single column. And going back to original request for showing Microsoft the money, currently pricing starts from $5 for 1 terabyte of processed data. You have some promo period now at the moment if you want to play around until the end of July. First 10 terabytes are free of charge, so keep in mind that until the end of July you can play for free. The exact price depends on the region, and you should definitely check how much would you be charged depending on where your data is. Also keep in mind that minimum chargeable amount per query is 10 megabytes. So even though you sometimes have a query that processed less than 10 megabytes of data, you will be charged as this minimum threshold was reached. Fine, so let's now go through the list of the items that goes on house, or if you prefer, that Microsoft will not charge you for. So what doesn't count as amount of data processed is querying server level metadata, stuff like logins, server level credentials, roles, and so on. Databases you created within your serverless SQL endpoint, as those databases contain no real data, so only metadata like users, schemas, views, external data sources, external file formats, etc. Metadata related queries because they don't process data from the storage. And finally, data definition language statements, except create statistics, which I explained previously how they work in serverless SQL. Up until recently, while Synapse Analytics was still not generally available, finding out how much a specific query costs was quite cumbersome task. There was no way to find data about the completed queries, only those that were in progress. But let's not look back, and let's talk about current state of affair regarding cost control in serverless SQL Pull. The first and most important feature is that you can set the maximum threshold for the amount of data processed. The number you define is in terabytes, just for you to be aware, and you can define the maximum amount of data processed on daily, weekly, and monthly level. How it's done? You can use user interface in Synapse Studio, or you can execute T-SQL statements. If you are hardcore T-SQL developer, you can execute T-SQL statements in your tool of choice. I still prefer SQL Server Management Studio to Azure Data Studio, so I will show you how it's done both from Synapse Studio and SQL Server Management Studio. So if we go to Synapse Studio and you see this Manage tab on the left, and you see that I have this built-in serverless pool provided. If you hover over here, you will see this small icon of, I think this is kind of money here. So if you click on this, on the right-hand side, you see the cost control window pops up, and you can see how much data you processed today, this week, this month, and you can set different limits on a daily level, weekly level, and monthly level. Fine, I don't do this now. If you go to SQL Server Management Studio, let's first check current limits, current setup. So if I select data from sys.configurations and execute this, you will see that my current limits are 10, 20, and 500. So same figures you saw a few minutes ago in Synapse Studio. And let's change this and let's set monthly limit to, for example, 100 instead of 500. So you will use this procedure SP set data process limit, providing two parameters, so type, which is daily, weekly, or monthly, and limit in terabytes. So if I execute this procedure and go back again and checked, you will see that now my new limit value is 100 on a monthly level. You can also check current amount of data processed. So if you query this system view DM external data processed, you can see that today I processed like almost 7 gigabytes and 26 gigabytes this week and this month because it just started. So in the end, I also did a calculation converting this amount of terabytes to real dollars. So here is the real money amount which I need to pay in the end. So for you, this session is free. For me, it's not. I will need to pay this amount in the end. Just kidding, of course, this is irrelevant, of course, but just to give you a better picture how you can calculate your costs. Fine, okay, as the session is aimed to explain different use cases of integration. Excuse me, I got some cold this morning. Different use cases of integration between Power BI and Azure Synapse. Here is the scenario that I've used for testing how these two products work in synergy. First of all, I'm using an open sourced famous yellow cab data set, which has around 1.5 billion rows in total, but I pulled only small portion of data. I have two CSV files, one for each month of January and February 2019. January file is, as you can see, 655 megabytes. The other one is 620. I also have two Parquet files containing exactly the same data. And you can see that Parquet files consume way less memory than CSV file. CSV format January file has around 7.6 million rows and February contains approximately 7 million rows. One disclaimer here, I haven't compared performance itself between those two, only costs. So how much would you pay for each of different scenarios? Here is the table which shows various use cases for both CSV and Parquet files with estimated costs in USD and short remark about the use case. I would really like that we have enough time to, go to Power BI and run each of those use cases separately and measure it one by one. But of course, that will take at least 1 hour, if not more than that. So in any case, I will share the presentation later so you can go and go back and check this table again. In short, for CSV files, there is no difference between using regular versus aggregated tables, as in both scenarios, the whole file needs to be scanned. When you compare import versus direct query mode scenario with CSV files, when you're importing data into tabular model of Power BI, you will be charged number of times that matches the number of your data refreshes. Simply said, if you refresh data once per day, you will pay only once for the amount of data processed. On the other hand, with direct query mode in place, number of visuals and number of users interacting with the report will directly affect the costs of your Power BI solution. As you probably know, when you're working with Power BI and use direct query mode, each time you interact with the visual, query will be sent to an underlying database, and each time you will need to pay for this generated query. Simply said, stay away from direct query whenever possible. The only edge case with CSV is if you pre-aggregate data within the Serverless SQL Pull, but that will have impact only on extremely large data sets because the amount of stream data, the amount of moved data, you remember this 27 megabytes in our previous example, will be lower and will have an impact on total amount of processed data. So it's not visible on smaller files. For Parquet files, it's completely different story. Pre-aggregating data in Serverless SQL Pull would literally do the magic. Don't forget that Parquet keeps the data in a columnar structure, so engine is capable to scan and eliminate scanning of unnecessary columns. So if you have frequently run queries, you can go and aggregate data within the view in Serverless SQL, and that will significantly reduce the costs of your Power BI solution. So here is the list of considerations you should keep in mind when you're creating Power BI solutions that use Synapse Serverless SQL Pull as a data source. I will repeat this again. No matter what you perform within the Serverless SQL Pull on top of CSV files, they will be fully scanned at the lowest level of the data preparation process. Remember that. And if you remember that, whenever possible, use Parquet files instead of CSV. Also, this is a general recommendation, not just related to Serverless SQL, but for Power BI in general. Whenever possible, import the data into Power BI. In this specific example with Serverless SQL, that means you will pay only when the data snapshot is being refreshed, not for every single query within the report. If you're dealing with Parquet files, whenever possible, create pre-aggregated data in form of views in the Serverless SQL Pull in the Synapse. As Serverless SQL Pull still doesn't support result set cache, keep in mind that each time you run the query, even if you're returning the same result set, the query will be generated and you will need to pay for it. Keep that in mind. If your analytical workloads require a high number of queries over a large data set, when I say large, I mean so large that import mode is not an option in Power BI, maybe you should consider storing data in the dedicated SQL Pull, as you will then pay fixed storage costs instead of data processing costs each time you query this large data set. Here, in order to additionally benefit from using this scenario, you should materialize the intermediate results using external tables and then import them into a dedicated SQL Pull. That way, your queries will read already prepared data instead of raw data. Okay, folks, that was from my side. Looking forward to hearing your questions. And in case that there is not enough time to answer all of them, I'll try to collect the questions and get back with the answers later.
We do have a couple questions.
Should I open the chat or?
It's in the chat, but
okay,
whatever you want to do, if you want to look, or I can just read them to you.
No problem. I will. Okay. Just fine. Can you speak to how traditional Kimball modeling concepts, slowly changing dimension types, can be leveraged in a modern data warehousing with semi non-structured? Yeah, that's still an issue, and there are some workarounds, but it's not, let's say, regular experience regarding slowly changing dimensions as we used to know in traditional data warehousing. So if you need to satisfy this requirement, then the only way to go is to use some persistent data storage like dedicated SQL Pull, where you can use these traditional concepts. Query performance of Serverless SQL Synapse compared to dedicated, it's typically depends. It depends how much power you provided to dedicated SQL Pull. In Serverless, it's automatically scaled, so it can happen that it runs faster for some queries in Serverless compared to dedicated. Also, it can be opposite. Depends on the query and depends on the computing power that you have in dedicated SQL Pull. Could you share some handy links for Synapse training? Yes, if you have time, you can check. There is Microsoft has official learning path for Azure Data Engineer certification. There are, I think, 25 different modules related to Synapse, not just to Serverless, but also to dedicated and for Spark and Azure Data Factory, all things that make this product. Okay, I've observed that when building dimensions of a flat source in Power Query, I'm using reference to the regional table source that Power Query rescans the source table. Is this considered a feature or something that is planned on being fixed?
Do you need clarification?
Yeah, please.
I was really excited about discovering Power Query's ability to do modeling. doing a lot of work against flat file sources, Excel files, whatnot, and just the concept of being able to take that flat source. Let's be more specific in terms of cost. Let's say it's a flat table that a DBA has dumped from different sources just for convenience for users. But you want to take that and get it into Power Query and remodel it, right? So say it's 100 million rows. And you want to take that flat table and redimension it, break out customer, date, so on and so forth. It seems like in Power Query, it all seems logical the way you can lay it out and reference the original query and build your indexed dimensions. But I've observed that every single time a referenced query is generated, it goes back to the original data source instead of doing it in memory. Does that make sense? And to me, if you look at what it's doing up in the service, this is just on-prem. So that same thing is happening in against service. You're going to be getting charged going back to that 100 million row table every time you're trying to pull out a dimension.
Okay, I get it now. I think this is a feature now. But as far as I know, they are working on it to improve this thing. But I don't know the details. Now it's clear when you clarified the whole problem. That's it. I think you don't have an option to, if you're referencing, I believe there is no option to somehow instruct Power BI to perform all those things in its memory. Especially with flat files and Excel files. I'm not sure if it's a normal SQL table, if query folding would help. I'm not sure. But for those things with Excel and CSV and flat files where there is no underlying querying language to, to push those filters down to the data source, I don't think it's possible to achieve this.
But you understand the concept, right? And what's kind of confusing about it, because you've already brought it into memory.
In the Power BI, yeah, you have something in Power BI, and you expect that if something referencing this thing in Power BI, that it will use the thing you make in Power BI without going down.
Exactly.
Yeah,
Especially
understand.
If you're revisiting a flat file over a semi-reliable WAN link or something like that. It's pretty frustrating.
That's how it is, I think.
Thank you.
You're welcome. Ranjit asked, can we not create multiple aggregated Parquet files to reduce the data processing cost? If you can just reiterate over it, multiple aggregated Parquet files, what exactly do you mean?
Hi, Nikola, this is Ranjit. So my question is, see, like, let's say your CSV file has 650 megabytes and the Parquet you created on top of the CSV had around 200 megabyte. But let's say in Power BI, we don't want that granularity. Let's say we want only probably 1,000 rows. So if we create Parquet files with lower or higher granularity, then whenever we refresh the Power BI, the data processing cost will be lower, correct?
Yeah, exactly. So you can create a view which will aggregate data from this Parquet file. So instead of having, I don't know, if this original Parquet file had 250 megabytes, it contained 30 columns. If you need just 5 or 6 or 10 columns, you can create a view which will pull only those 10 columns, and amount of data processed will be 3 times less than if you are scanning whole Parquet file. So
But
does that make sense?
I was not. I was not thinking about the view. See, what if we have an ETL or the data factory in a pipeline that creates a new Parquet file with
Yeah, that's also
lesser
possible.
records.
Yeah. You can use this create external table as select, so you can select just specific portion of data from this file and create a new Parquet file based on it. So CTAS creates a new Parquet file. So if you need to combine data from multiple Parquet files, that's also possible. You will just create external table as select, put everything in this SQL statement, and you will get a new Parquet file which contains data that you need.
Yep. Thank you.
You're welcome. As far as I see no more questions, if someone remembers later, yeah, ping me on Twitter or LinkedIn. No problems.
Thank you so much, Nikola. We appreciate your time today.
Thank you all. Thank you, Laurie, for being awesome hosts, and thank you everyone for attending the session. Enjoy the rest of SQL Saturday LA.
Thank you.
Thank you all. Bye bye. Have a nice day.
Okay, bye.
Bye.
Thanks again.
Thank you.